So in this video clip we're going to be looking at GCSE questions on area and perimeter, predominantly aimed at the intermediate tier. So we'll be looking at circles, triangles, rectangles, semicircles, and these things, trapezium. Now the trapezium is one of the few formulas that you're given at the front of an intermediate or foundation tier paper for the area of it. Looks exactly as I've put here. There's a diagram of trapezium. You've got A and B, which are the two parallel sides. They don't always have to be lying horizontally, they could be vertical. And H is the shortest distance, the perpendicular right angle distance between the two parallel sides. And the formula is written, and I've made it a little bit larger there, half bracket A plus B H. What you need to do is work out the brackets first, so that's telling you to add the parallel sides together, then half it, and then multiply what you get by the distance between them. So it's half the sum of the parallel sides times the distance between them. You can do that on your calculator if it's a calculator allowed paper. So for example, we could put in the half as a fraction, the bracket, and let's say A was 2 and B was 3. The only bit we'd have to add is the times, which joins the H to the bracket. So let's say there was a distance of 4 centimeters between them. So we type it in like that, press equals, and that will get our answer. So it's half the sum of the parallel sides. You've got to work that bit out first. So if you're not using brackets on your calculator, you'd have to press equals at that point, times the height, and that gives you the area. And the units for area would be square centimeters, cm with a little 2 above it, or meters, or whatever the units of the lengths are. The other two formulas that you need to know, and you have to recall these yourself, for the area of a triangle, which you tend to learn as half base times height, but we'll take a look in the very first question how that breaks down. And also for the area of a circle, pi r squared. And for grade C and B questions, they'll challenge you to use and apply these formula either within a context, for example, cost of carpeting a room or tiling a wall, or in combined shapes where you've got semicircles stuck on rectangles or whatever. You may be asked, you also could be given an area of perimeter and actually work backwards to find the length of an unknown side. And examples of all of those things are contained in this pack. So where do we start? We start with a triangle. Calculate the area of the triangle and state the units of your answer. We'll come back to that last bit. But first of all, the area of the triangle. You tend to learn this formula, which is half base times height. So on this particular thing, that is your base, which you don't know, and this would be the height, which you don't know. But if you turn the triangle round to make that your base, the height is always a perpendicular height, which means it's at right angles. So what you've got here is actually half a square, 8 by 8. So the base is 8 and the perpendicular height is 8. So the area is a half base times height, where that's the base and that's the perpendicular height. So 8 8s is 64, half of 64 is 32. Now because this question is explicitly telling you you must give the units of your answer, even though you've done all the maths, leaving it like that would only get you 2 out of 3 marks. In order to get the final mark, you need to state the units. You should know that length is always centimeters or meters or kilometers. Area is always to the power 2. It's squared because you're multiplying a length by a length. Volume would be cubed because you're multiplying a length by a length by a length. So to get those 3 marks, you need to include that centimeters squared. Okay, question 2. Let's see if I can improve the light here. It's a bit better. Olga wants to paint one side of a garden wall. The wall is 2 meters high and 35 meters long. So there's a sketch of the wall. She's found the following information about the special paint that she needs. It is only sold in 5 litre and 2 litre tins. 1 litre is enough to cover an area of 6 square metres, and the tins are sold at £12 for a 5 litre tin and £6 for a 2 litre tin. So what we need to do is find the least amount she has to pay for enough paint to cover the wall. So the first thing to do is to work out how many square metres there are in that wall. So what is the area of the wall? So the area of the wall, it's a rectangle, so it's just length times width, 2 times 35, which is 70, and the units would be square metres. So that's how much wall we've got to cover, and now we work with the paint. We know that 1 litre of paint will cover 6 square metres, and we've got 2 different types of tin. So if we can work out how much one 5 litre tin covers, so coverage of a 5 litre tin, so that will be, so 1 litre covers 6 square metres, so 5 litres will cover 5 lots of 6, which is 30 square metres. So one 5 litre tin will cover 30. I need 70, so 2 5 litre tins will get me to 60. So what about the 2 litre tin? Will be 2 lots of 6 equals 12 square metres. So in order to cover an area of 70 square metres, I could get 3 5 litre tins, but then I'm going to have a lot of waste. Or I could get 2 5 litre tins, which will give me 60, and one of those which will make it up to 72. So I will need 2 5 litre tins, and they're going to cost me £12 each, £24, and 1 2 litre tin, which is going to cost me £6. So in total, £30. And you can see there when you print these out, the numerical answer is there, just so you know that you've got that right. Okay. Question 3. A cross-shaped pattern is made by arranging 4 identical rectangles around the sides of a square as shown in the diagram below. So I've got a square there which is really faint, so I'll just add those dotted lines. So the side of the square makes up the shorter of the sides of each rectangle, and they're identical. So that one, that one, that one, that one, they're all the same. The area of the square is 36 centimeters squared. So I know that that side and that side are the same length, and when they multiply together they make 36. So 36 is a square number, and you get 36 when you multiply 6 by 6. So the side of the square equals the shorter side of rectangle and equals 6 centimeters, because its area because 6 times 6 is 36, so that's the area of the rectangle. So I've used that fact. The area of each rectangle is 1.5 times the area of the square. So area of rectangle equals 1.5 times 36. Now I'm not sure whether this came off a calculator allowed paper or a calculator not allowed. So if we're assuming that it's not allowed, what 1.5 times 36 is 1 lot of 36 plus a half of it again, which is 18. So 8 and 6 is 14, 3, 4, 5. So the area of each rectangle is 54 square centimetres. Now if you were allowed to use a calculator, you'd have just done 1.5 times 36, which is 54. But you need to be able to deal with that without. So now, I know that each of these rectangles has got a width of 6. And I know that their area is 54. So something times 6 must equal 54. So going through my 6 times table, I know that 9 6s are 54. So now that means that each of these is 9. And what I want to do is work out the perimeter of the cross-shaped pattern. So I've got to, for perimeter, if I start there, I've got to go 9 plus 9 is 18, plus 6 is 24, plus 9 is 33, plus 9 is 42, plus 6 is 48, plus 9 is 57, plus 9 is 66, 72, 81, 90, 96. So the total distance around the outside of that shape equals 96, and I can see there that's what the correct answer is. So I've done that by adding up the total distance around the outside of the shape, and again state the units of your answer. It's perimeter, it's distance, it's length, it's just centimeters. So that's an example of a question where you have to work backwards from a given area to find the length of an unknown side. Question 4. A company's logo is displayed on the outside of its factory wall. The shape of the logo is made using a rectangle, a right angle triangle and a semicircle. So rectangle, right angle triangle and semicircle. Some of the lengths are shown on the diagram. Calculate the total area of this logo, and then we'll leave this bit to last. Give your answer correct to 1 decimal place. So I've got a rectangle, I've got a triangle, I've got a semicircle. So if I call them A, B and C. Area of shape A, nice and easy, length times width, 20 square meters. Now for the area of B, you think half base times height, but remember that you're looking for a pair of measurements that are at right angles to each other. So that's my height, which is 10. I need to know the base. Well, in this rectangle, if that's 5, this is 5 over here as well. So half base times height is a half times 5 times 10. 5 tens are 50, half of it 25 meters squared. Then we come to the semicircle. So this is my pi r squared for a circle. So I need to know the radius of this circle, this semicircle. Now if it's 4, because this rectangle, if that's 4, then this is 4 down here as well, which is the diameter, which means the radius is half the diameter, which is 2. So the area of C will be pi times radius squared if it was a full circle, but because it's a semicircle, I got to half it. Half the area of a full circle. So if I work out what that is now, I can type that on my calculator exactly as I see it. Pi, shift, oh hang on, it's off the scale a minute. I've had to zoom in. So pi is there above the times 10 to. So I do shift, sorry, start again. Bring it a bit more light. Shift pi times 2 squared times a half. No, not quarter, a half. Okay, so I've typed that exactly as I see it. You can take shortcuts. Instead of a half, you could write 0.5. You could do 2 squared in your head, it's 4. Doesn't matter. What's important is you get the right answer. The calculator would give it you in terms of pi, so 2 pi, but I want it in terms of 1 decimal place. So at this point, I'm going to write down more. I'm not going to worry about that 1 decimal place bit yet. I'm just going to jot down the decimal parts well beyond the 1 decimal place, because I may make a mistake with the 1 decimal place, but I still want to show the examiner that I've correctly worked out that semicircle. So now the total area is the area of the rectangle plus the area of the triangle plus the area of the semicircle. On my calculator, I'm not cancelling that, I'm just going to add to it. So I'm just going to add 20, add 25, and I get 51.28318 da 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 da. Now, I get my 4 out of 5. But I need to give my answer correct to 1 decimal place. You need to be able to deal with significant figures and decimal places. Decimal places, you start counting beyond the decimal point. So to 1 decimal place, my answer is either going to be 51.2 or 51.3, depending on which it's closest to. And the way that you're taught is to look at the next digit after the 1 decimal place. If it's 5 or more, it means it's closer to 51.3. This question doesn't ask you for the units, so there's no additional marks for putting it in, but it's good practice to do so. So 51.3 square meters for that shape. Now we come to the area of the trapezium. So remember, you're given this on your question paper, the front page, so don't worry about learning it, but you do have to apply it correctly. So it's a half. A plus B, sum of the parallel sides, 5.6 plus 9.8. And then they've given you a choice, just to confuse you, of sort of vertical measurements. We've got a 3.3 there and a 2.8 there. It's clear it's the 2.8. It's the perpendicular distance between them, not that one which is at a slant. So we've got to put in the times. And we whack that onto our calculator. Fraction button, half, open brackets, 5.6 plus 9.8 times 2.8. So 21.56. You can see there is correct. And this is another one where there's a unit mark. So if you leave it like that, even though you've done all the nasty maths, you're not going to get the unit mark for centimeters squared. Okay, question 6. The area of a circle is 36 pi, so it's given in terms of pi. So you know that the area is pi r squared. So pi r squared must equal 36 pi. Now we're going to find out what r is, so we're going to do a little bit of sort of algebra equations here. To get the r squared on its own, I have to divide by pi. And what that does is it cancels out the pi. So we get r squared is 36. The opposite of squaring is square rooting. And I know that square root of 36 is 6. So the radius of that circle is 6, as you see there. Question 7. Tents leave different shapes on the grass when packed away. Lowry's tent leaves the shape of a rectangle on the grass. The length of Lowry's tent is twice its width. The width of her tent is 2.3 meters. Tom's tent leaves the shape of a square on the grass. The perimeter of the shape left on the grass by each of their tents is the same. Calculate the length of the shape left by Tom's tent. Okay, a lot of information there, so let's go back to the start. Lowry's tent leaves the shape of a rectangle on the grass. The length of Lowry's tent is twice its width. Its width is 2.3, so it's 2.3 that way. It's double that in length. You double 2.3, you get 4.6. Tom's tent leaves the shape of a square on the grass. The perimeter of the shape left on the grass by each of their tents is the same. So the perimeter of that will be 4.6 plus 2.3 plus another 4.6 plus another 2.3. So 4.6 plus 4.6 plus 2.3 plus 2.3 is 13.8 meters because it's distance. Tom's is a square. So Tom's is the same side. So that one, that one, that one and that one are identical, and their perimeter, so if I put question marks there, I'm going to have four question marks will give me the perimeter of 13.8. So to find out what one question mark is, I've got to divide by 4. And when I divide by 4, I get 3.45, and the units are perimeter, length, meters. Dewey's tent leaves a circular shape on the grass. The radius of the shape is 1.8 meters. Calculate the area of the shape left by Dewey's tent. So it's a circle. Area pi r squared, you've got to remember, equals pi times 1.8, because it's telling me what the radius is, squared. So on your calculator, the pi button times 1.8, the squared button, SD to turn it into a decimal, 10.178 da 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 da, rounded to one decimal place. And the reason I'm rounding it to one decimal place is because the measurement they're giving me is to one decimal place. So 10.1 or 10.2, look at the next one, bigger than 5, 10.2, its units are meters and area is squared. 10.2 meters squared. Question 8. Diagram shows a sail. The top part of the sail is a triangle with perpendicular height x meters. So there's my triangle, perpendicular height x meters. The bottom part of the sail is a trapezium with a perpendicular height x meters. The area of the triangle is 12 square meters. Calculate the area of the trapezium. So I know here, triangle, area equals a half times its base, which is 6, times its height, which is x, and I know that's 12. Half of 6 is 3. 3 times something is 12. Divide both sides by 3. So x is 4 meters. So if I know that is 4, I know that the height of this is also 4. So I'm going back now to my formula for area of the trapezium. Half a plus b times height. So for my trapezium, the area equals a half a plus b, sum of the parallel sides, times the distance between them, which is 4. Now let's take this as a question that is non-calculator. 6 plus 14 is 20. So I've worked that bit out first. Then, well, you can do this in any order you like. You can do half of 20 is 10 times 4 is 40, or you can do 20 times 4 is 80, half of 80 is 40, or you could do half of 4 is 2 times 20 is 40. Doesn't matter which, or when you get it down to that point, you finished all your addition and subtraction. When you're multiplying, it doesn't matter which order you do things. So half of 20 is 10, 10 times 4 is 40, and the units are meters squared. Question 9. So this is an OCW question. There's an additional 2 marks. 2 out of those 7 marks are for how you communicate the maths that you're going to work through. Doesn't mean you write a story or an essay. It just means you're clear what each line of maths is doing and be consistent with your units. So Rodri has a tile in the shape of a trapezium. So already I'm thinking area. I'm looking for my parallel sides and the shortest distance between them, the perpendicular distance between them. Rodri decides to cover the tile with gold leaf. Gold leaf is bought as a book of sheets that can be cut to size without any waste. Each sheet of gold leaf measures 2.7 centimeters by 4 centimeters. And a book of 5 sheets of gold leaf costs £15.50. Calculate the cost of the gold leaf used to cover Rodri's tile. So the first thing I want to do is work out how many square centimeters my tile covers. So I need the area of the tile. So that's all I'm going to write. And I know now my half parallel sides, 26 plus 10 times the distance between them isn't 20, it's 12. I'll assume this one is a calculator allowed paper. So fraction, half, open bracket, 26 plus 10 times 12. So it's typed in exactly as I've written it. So the area of the tile is 216, and I also said for that OCW I want to be consistent with my units. It's area, it's centimeters, so it's centimeters squared. Now, what I need to do now is to find out how many books I need to buy of this gold leaf in order to cover my tile. So the area of one sheet is going to be 2.7 times 4. So one sheet of gold, 2.7 times 4, because it's a rectangle. That's 10.8 square centimeters. And there are 5 sheets in a book. So the area of gold per book is 10.8 times 5 pages. 54 square centimeters. So I want to now find out how many books I need to buy to cover 216 square centimeters. So number of books needed will be the total area I've got to cover divided by the area per book. So on my calculator, I'm going to cancel that and do 216 divided by 54, which is 4 books. Each book costs £15.50. Cost of 4 books is 4 lots of £15.50, 62 quid. So that for me gets the 5 marks for the maths because I got £62, and also it gets the 2 marks for the OCW because each line of maths I'm clearly stating what I'm calculating, and then I'm consistently unitizing area, 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 number of what? Books, cost, pounds. And that's what earns you those marks. Not a story, well, first of all I'm going to do this, then I'm going to do that. And then the final question in this pack, something to press on. A beanie hat is to be made from a piece of fabric. 1 square metre of this fabric weighs 420 grams. The diagram below shows the pattern for the beanie hat consisting of 2 identical semicircles attached to a rectangle. How much will the fabric in this beanie hat weigh? Well, we've got to work out its area because each square metre has a weight to it. So because that's in square metres, I need to work this out in square metres as well. So 56 centimetres is 0.56 meters, 34 centimeters is 0.34 meters. It's easier to do that conversion before you start multiplying. Now, if I get a ruler and create a rectangle and those semicircles, I should see that the distance across the semicircle, which is the diameter, is going to be half of 56, or half of 0.56, which is 0.28. So that is 0.28, that is 0.28. Now area is pi r squared. I need the radius. The radius is half the diameter, so that's going to be 0.14. That's going to be 0.14. And because I know that, and I know that that is 0.34, that allows me to work out the height of that rectangle, because it's going to be 0.34 less 0.14. So 0.34 less is 0.2. So the area of the rectangle is 0.56 times 0.2. So that's 0.112 square meters. Now I've got two semicircles. So I can put them together to make one circle with a radius of 0.14. So the area of those two is going to be pi times 0.14 squared. So pi times 0.14 squared, 0.061575 ... So the total area of that shape in square meters pattern will be 0.6155 plus the rectangle, which equals, so if I just add 0.112 onto that, I get 0.17357 ... I'm working here to two decimal places, so when I finish I'll do the same. Now 1 square meter of fabric weighs 420, so 2 would weigh twice as much, 3 times as much, half as much, 0.1735 ... that times as much. So to work out the weight will be 420 times whatever's on the calculator screen. Sorry, it's off the screen. So 420 is the weight per meter, square meter, times our square meters, which I haven't been putting on here. So that will give us a weight. So what's on my calculator screen times 420 equals 72.9, and you can see there that's a nice place to round it, grams, which is the answer you're given. So that was a bit trickier. You've got to think carefully about how to get the diameter, from the diameter how to get the radius, from the radius how that helps you to work out the height of the rectangle. So of all the questions there, you're up to sort of grade B standard when you're dealing with that very last question. Okay, so hopefully that's helped refresh your memory on areas of circles, rectangles, triangles and trapezia.